seen by the primary EMF, which changes with the rotation of camshaft. This results in changes in the magnetic flux with rotation of the camshaft. Due to this change in magnetic flux with rotation of cam, the flux linkage of secondary winding which also changes. So therefore, as per the transformer action, an EMF is induced in secondary winding. The magnitude of induced EMF will depend on the rate of change of rotation. The more the change of rotation, the more will be the rate of change of flux with respect to, and hence more EMF will be produced. So when you are having the two secondary windings which are connected in series, but it has to be connected in phase condition. So this is done to get a single output voltage of the transformer. If secondary winding and the E0 be the EMF induced into secondary windings voltage respectively. So what will happen abdina, the net output voltage is nothing but an secondary winding voltage minus the secondary winding voltage at the minus 2. So in the first condition, we'll have when the shaft is placed at the null portion, and the induced EMF in secondary winding are similar, although reverse in phase. So thus the differential output potential will be 0, and the condition will be that E1 is equivalent to E2, where E0 is equivalent to E1 minus E2 is equivalent to 0. Similarly, when the core is certain, the thing is to be the position. So that is the clockwise direction. When the shaft rotates in clockwise direction, so what will happen abdina? Actually, under normal condition of RVDT, the flux linkage of both the secondary windings are same due to the symmetrical placing with respect to primary and core. So therefore, the induced EMF of secondary winding and both the windings will be equal. Hence, output voltage E0 of the transducer in such condition is 0. So the normal portion of RVDT is called to be an held portion. When the case of in clockwise direction, the rotation of cam causes an increasing voltage in one of the secondary winding. So that is the more section of core will enter across the primary winding. Therefore, the induced EMF across the primary winding is higher than the secondary winding. So the differential output potential is positive, and the condition will be E1 is greater than E2. So you'll have a positive direction. The thing is to be that when you're having of an anti-clockwise direction, it leads to increase in voltage E version of another secondary winding. So thus the direction as well as the magnitude of angular rotation, which can be ascertained from the magnitude and phase of transducer output voltage. So the third condition, when the shaft rotates in the direction of anti-clockwise, more section of the core will be entered across secondary winding. Thus the induced EMF across secondary coil is higher than the primary coil. Hence the differential output potential is negative. That means 1800 phase shift, and the condition will be E1 is less than E2. Or E0 is equivalent to E1 minus E2 will be then negative. So in case of the anti-clockwise rotation, the value of ESN will be more than that of ES2, and hence ES1 minus ES2 will be positive. In this case, we say that the output voltage E0 is in phase with the primary voltage. With the same logic, when cam is rotated in clockwise direction, the output voltage will be negative, that is out of phase with the primary voltage overall. Okay, so this is about three different cases that what we are analyzing. So the next thing we have to discuss the advantages and disadvantages. So when you are saying about an advantages, actually the consistency of RVDT is high, the exactness of RVDT is high, and when you are saying about an lifespan, it is also long. The performance will be repeatable. When you are saying about an construction, it is compact and strong. So we'll have a durability, we'll have a low cost. It is easy to handle electronic components, where the resolution will be infinite overall. The linearity will be excellent, and will have a wide range of dimension ranges. Whereas in the case of a disadvantage, the contact among the measuring exterior as well as the nozzle is not possible for all time. And similarly, the output of the RVDT is linear, so it restricts the usability. And the last thing we are need to know, what are all the applications behind over on it. Actually, it can be used as a fuel valve as well as hydraulic. It can be used as a modern machine tools. We'll have a control cockpit. It can be used for control fuels. It can be used for brake with cable systems. And similarly, it can use over on engines bleed air systems. It is used in robotics, aircraft, avionics, process control industry, weapon and torpedo system, engine fuel control, nose wheel steering systems, fly-by-wire systems, push reverser, and actuators for controlling flight as well as the engine. So we'll have an ecological control system. Okay. So this is about an RVDT construction, working principle, and advantages and disadvantages and the applications behind over on. The next thing we can see in the next class. Thank you all.